I was inspired by this circuit from 1966 from worldradiohistory.com, and I found this circuit, and they told it was a circuit via which you can change square waves into triangle waves. Well, the whole idea, the key idea of this circuit is this capacitor here. Here we send in the square wave. This first part of the circuit changes it into a triangle wave, and this is the amplifier. And of course, when we want to convert all kinds of frequencies from square waves to triangle waves, you need different capacitors. For this capacitor C1 and also C2, that's the coupling capacitor to the amplifier stage, etc, etc. This was made, as far as I could see, with germanium transistors, of course, 1961. And here are, say, the different capacitors needed for the different frequency bands. 5 cycles, 2000 microfarad. Well, that's a very big value. Coupling capacitor C2 must be 1000 microfarad, and C3, that is the output capacitor, must be 500 microfarad. And on 5 kilocycles, it is 2 microfarad for the C1 and 1 microfarad for the coupling capacitor, and 500 nanofarad for the C3, that's the output capacitor. Of course, it's made with PNP transistors, and I think it was made for germanium transistors, so I had to change it a little bit to NPN transistors, normal NPN transistors, and I say my idea was, let us give it a try, perhaps it works okay. And I did only an experiment of 1 hour, 1.5 hour to get an idea whether this could work, and yes, it works. I could not elaborate it, I also don't want to elaborate it. I could get it working between, say, 4 kilohertz and 13 kilohertz, this converter. But anyway, so let's go to my workbench. I have the circuit now on the breadboard, say a kind of breadboard. First the schematic, and now it is of course made with modern NPN transistors. Well, let me give the tag Radio Fun 232 18 January 2026. Here are the 2 transistors that I've used. NPN silicon transistors with an amplification factor in the order of 200 up to 300. Here we send in the square wave, and here we harvest in a certain way the triangle wave, and well, this is what it is. I don't want to pay too much attention to it. It is a typical circuit that needs a lot of more elaboration, experiments, etc, etc. Also the reason why I've given here potentiometers, biasing the whole circuit, etc, etc. In the original schematic you will find a direct connection from the emitter to the ground. It did not work, I tested it. So anyway, here is it on the breadboard, kind of breadboard. It works. That's the most important thing to tell. But say below 4 kilocycles the waveform is no longer a triangle wave. This is a kind of triangle wave. It's now on 4 kilohertz. And let's lift the square wave frequency up to a higher frequency. I do that here. So let's go. The triangle wave gets better. The waveform gets better, but the amplitude changes substantially. Now we are on 13 kilohertz, and that's more or less, in my opinion, the maximum that this circuit can bring us. Not bad here. So with this setup, first setup, I don't want to pay more than 1 or 2 hours to this setup. It works. Anyway, thanks for watching. That's the first thing to say. I always appreciate it when you watch my videos, and I hope they are helpful for every serious electronics amateur, etc. So this is what the circuit can bring. Back to the schematic. Let's keep it very short. Below, say on the lower frequencies, you see this change in the waveform. Amplitude changes substantially, and the waveform changes to a bad, not a bad waveform, but no longer a triangle wave. So this is, for instance, say 900 hertz or so. Then we have this waveform. But on 5 kilohertz we have this waveform. That's not bad. And thanks for watching again.